This image is burned into the retinas of anyone who has ever watched time-lapse videos of global logistics. Dazzling white cruise ships and heavily laden container ships glide silently through a narrow concrete corridor surrounded by emerald jungles. It seems like a triumph of human intellect, a flawless conveyor belt where continents part at the snap of an engineer's fingers. We are sold an image of ultimate victory over geography, monumental and eternal. But the water in this corridor can be deceiving. If you look away from the gleaming superstructures of the ships and look at the edges of the concrete troughs, you can see traces of a chronic disaster.
Behind this facade of well-oiled logistics lies a story not of conquering nature, but of an endless, exhausting war of attrition.
A story of daily landslides, critical shortages of fresh water, corrosive salt, and a system that devours itself. The bottom of this canal is littered with abandoned excavators. The mountain slopes are covered with cracks, ready at any moment to unleash millions of tons of rock onto passing ships. The lakes that feed the system are drying up, and the concrete locks are slowly succumbing to the pressure of the ocean water. This is not just a transport artery. It is an open, unhealed geological wound on the body of the continent.
An artificial life support system for the global economy, operating at the limits of its physical capabilities and requiring daily medical intervention.
An experiment in forcibly altering the planet's blood circulation that has spiraled out of control. By the end of this dive, you will understand why the passage of each ship is not routine, but a mathematical risk. You will see that this concrete corridor does not connect the oceans, but desperately tries to keep them at a distance, paying for it with the resources of an entire region. Let's go back to point zero, to a time when there were no airlocks, no steel gates, no geopolitics, only an impenetrable wall of tropical forest, poisonous swamp vapors, and a continuous mountain range insurmountable to any human machine. The land of the Isthmus of Panama was completely hostile to the idea of through traffic. It was not just a narrow strip of land on the map, it was a dense, three-dimensional labyrinth of volcanic clay, bottomless swamps, and rivers that changed course after every rainstorm. The French, who were the first to arrive here, failed to see the reality. They brought with them drawings based on arrogance. Ferdinand de Lesseps viewed Panama through the prism of his triumph in Egypt. He built the Suez Canal and believed he understood the algorithm for cutting through continents. His logic was linear. You just need to dig a trench at sea level from one body of water to another. Suez was a flat, sandy desert. Panama was a mountainous jungle sponge. Lesseps' plan was a death sentence for the project even before the first shovel was lifted. He ignored the elevation difference, ignored the rainy season, and ignored the geology. He planned to cut through the mountains, lowering the bottom of the trench below sea level. The machines brought in from Europe were not designed for tropical hell. Steam excavators that easily dug through Egyptian sand got stuck in wet clay here. The teeth of the buckets broke on hidden basalt boulders. The iron began to rust in the first few weeks due to the 100% humidity saturated with salt. Nature responded to the invasion immediately. As soon as French workers dug a trench, a tropical downpour began. In a few hours, the Chagres River could rise 10 meters.
Mud flows washed away the rails, flooded the locomotives, and completely buried what had been dug for months.
The work turned into a Sisyphean task. People removed a ton of rock, and the jungle dumped 2 tons on them. The earth here did not hold its shape. The clay, saturated with water, flowed like thick soup. The slope angle that European engineers had calculated from textbooks did not work in Panama. The walls of the trench constantly collapsed. The French tried to take the isthmus by brute force and sheer numbers. Thousands of workers were brought in from the West Indies to work on the construction site. But then a factor came into play that no engineering plan had taken into account. Biology proved stronger than mechanics. Yellow fever and malaria began to systematically wipe out the camps. It was not an outbreak, but a steady, mathematically stable process of destruction. People were dying by the thousands.
The mortality rate was so high that the ships that brought in new workers took back ballast in the form of empty coffins.
The hospitals built by the French became epicenters of death. Out of fear of crawling ants, the legs of hospital beds were placed in bowls of water. In the stagnant water of the tropics, mosquitoes, carriers of yellow fever, multiplied exponentially. Doctors, without realizing it, cultivated death right in the wards with their own hands. The project's financial system collapsed under the weight of corpses and cubic meters of returning mud. The money of French investors dissolved in the Panamanian swamp. The shares depreciated, turning into paper waste. The company went bankrupt, leaving behind abandoned equipment and kilometers of meaningless, flooded ditches. The jungle swallowed the metal in a few years. Vines entwined the rusty steam boilers. The illusion of a straight, flat path at sea level was shattered. The project proved that it would not yield to a linear approach. The form had to be changed. The United States watched the French failure with pragmatic interest. For America, the canal was not a matter of prestige or commercial profit. It was a matter of imperial survival. During the Spanish-American War, it took a warship 60 days to circumnavigate South America. 2 oceans made the fleet vulnerable. The canal was needed as a military instrument for the transfer of power. President Theodore Roosevelt did not immediately go to war with the landscape. He began with geopolitical surgery. Colombia, which then owned the isthmus, refused to give up the land on Washington's terms. The response was immediate and surgically precise. American warships blocked the coast. With financial and military support from the U.S., a group of Panamanian separatists declared independence. The new state was created with a single purpose: to become the legal shell for an engineering project. Panama was born as a service mechanism for the future trench. When American engineers arrived at the ruins of the French construction site, they saw chaos. Thousands of tons of rotting equipment and a complete lack of infrastructure. The project's first chief engineer, John Stevens, made a paradoxical decision. He ordered all earthworks to be stopped. Stevens understood the basic law of systems. It is impossible to digest more rock than the transport network can carry away. He started not with shovels, but with rails.
He rebuilt the Panama Railroad, turning it into a giant, continuously operating conveyor belt for removing soil.
At the same time, a second critical problem was being solved, a biological one. Dr. William Gorgas declared war not on the mountains, but on the mosquitoes. It was a total, unprecedented cleansing of the ecosystem. Swamps were drained, forests were cut down, and gallons of oil were poured into every puddle and every barrel of water. The cities of the isthmus were subjected to harsh fumigation. Special teams sealed houses and fumigated them with sulfur. It was a military campaign against the biosphere. Within 2 years, yellow fever was completely eradicated. The system was sterilized for the safe introduction of technology. But the main revolution took place in the blueprints. Stevens mathematically proved to Roosevelt that a sea-level canal would kill the project just as the French one had. The Culebra mountain range would never stop crumbling if dug to the bottom. The amount of earthwork exceeded the capabilities of humanity. A decision was made that violated the very logic of the direct route. If it was impossible to lower the mountain to sea level, then the sea would have to be raised to the level of the mountain. The concept changed from a trench to a water bridge. This meant creating a complex system of locks in a huge artificial lake 26 meters above sea level.
Ships had to climb concrete steps, sail over the jungle, and descend back down.
This saved them from having to dig the deepest section. But this salvation came at a new price. The canal was no longer just a dugout channel. It had become a colossal mechanism dependent on electricity, complex hydraulics, and, most importantly, uninterrupted rainfall. The illusion of a natural strait was dead. A machine was born. Will humans ever truly conquer wild nature? Or is any victory over it just a temporary illusion? Even with the transition to a new, so-called elevated construction plan, the main obstacle remained insurmountable. The Continental Divide, a mighty mountain range separating 2 oceans, had to be literally broken through. A 14-kilometer-long section, given the grim name of the Culebra Cutoff, became the epicenter of incredible human suffering. It was the most brutal and large-scale act of opening up the Earth's crust in the history of our civilization. The mountain resisted human intervention so fiercely as if it were a huge living organism defending its integrity. The problem was that the local rocks were not monolithic and reliable. The entire ridge was an unstable cake of soft clays, volcanic ash, and very fragile shales. Under the weight of endless tropical downpours, this geological cake instantly lost its cohesion between layers and began to slide down. Landslides became a daily nightmare for builders, wiping out months of hard work.
Workers could spend weeks digging into the ground, deepening the trench meter by meter, but in just one night, the situation would change.
Millions of cubic meters of heavy rock would collapse into the pit, instantly burying excavators, railroad tracks, and living people. The earth in the Culebra excavation behaved completely unpredictably. It did not just fall on the workers from above, it literally squeezed out from below. Under the enormous pressure of the neighboring mountains, the bottom of the trench sometimes suddenly bulged upwards several meters right before their eyes. It looked terrifying as the earth spewed heavy steel rails high into the air with tremendous force. The engineers had to admit that their previous calculations were wrong and completely changed their strategy. They switched to an exhausting tactic of attrition, realizing that the mountain could not be conquered by conventional methods. The only way to defeat Culebra was to dig faster than the mountain itself could slide back into the trench. To implement this crazy plan, unprecedented firepower and technology were brought to the construction site. Dynamite became the main and perhaps the only tool in man's harsh dialogue with this rebellious landscape. Every day, tons of powerful explosives were placed in deep holes on the slopes of the mountains, turning the construction site into a war zone. The roar of the explosions was so deafening that people lost their hearing, and the earth shook for miles around. Thick smoke from the pipes of dozens of huge excavators covered the sky, turning day into twilight. The clang of metal against stone and the cries of people merged into a single, incessant roar of an industrial monster. It was a veritable factory of emptiness in the middle of the impenetrable jungle. But dynamite behaved extremely treacherously and was often deadly dangerous in the extreme tropics. Due to the intense heat, premature spontaneous detonations often occurred in the well shafts. Entire teams of experienced blasters were blown to pieces without warning. This risk was factored into the project budget by management in advance.
Human life in those years was worth much less than even a short, simple Bucyrus steam excavator.
Rock excavation went on around the clock, without breaks for rest or bad weather, driven by a tight schedule. Trains loaded to the brim with excavated soil departed from the worksite literally every minute. But this soil was not simply dumped somewhere nearby. It was used to create another part of the grandiose system. Thousands of tons of rock were transported many kilometers away to build the giant Gatun Dam. The mountain was essentially dismantled piece by piece in one place and moved to another to block the flow of the capricious river. In the trench itself, the air temperature often reached 50 degrees Celsius during the day. The hot air hardly moved, trapped between the sheer walls of black rock heated by the sun. People were forced to breathe thick coal dust, acrid steam, and harmful fumes from burnt dynamite. They cut through the continent almost blindly, constantly waiting for the next landslide to set their work back months. The famous landslide, called Cucaracha, instantly swept away all the engineers' hopes for a quick and easy victory. A huge mud glacier slowly but surely crept into the trench over several years. It was impossible to blow it up with dynamite or stop it even with the strongest retaining walls. In the end, the engineers simply gave up and continued to methodically scoop out the liquid mud with buckets until the flow finally dried up on its own. By the time all the work was completed, the Culebra excavation was 3 times wider than originally planned. The mountain forced man to change all his plans and submit to the harsh laws of geology. A deep cut was made in the body of the continent, but the edges of this man-made wound never fully healed. Landslides continue in this area to this day, requiring constant attention and enormous cost for cleanup. The Pyramid of Cheops was a struggle with the weight of stone, and the Panama Canal became an eternal battle with the earth itself. Will this wound ever heal, or will the oceans always demand new sacrifices to maintain the passage? How can the planet itself be made to work for the benefit of humanity without using a single pump? While a brutal and bloody physical battle with the earth was raging in the mountains of Panama, a mechanism of unprecedented precision was being built on the coast. We are talking about the famous locks of the Panama Canal, which amazed the imagination with their scale. This was no longer simple earthwork, but the most complex macro-jewelry mechanics embodied in concrete and steel. Never before in history had humanity poured such a colossal amount of concrete in one specific place. Millions of barrels of cement were needed to build the walls of the locks, whose thickness is comparable to that of powerful medieval fortresses. Huge rail cranes moved continuously over the entire construction site like giant spiders. They continuously dumped tons of liquid stone into specially prepared wooden molds. The heat emanating from the hardening concrete mass was so intense that workers inside the structures risked literally burning their lungs. The locks were concrete basins of truly titanic proportions. Their main task was to reliably hold the weight of a modern ocean-going vessel and millions of liters of water. But the true genius of this complex system lay in the complete absence of powerful pumps. The entire mechanism, which lifted huge ships to the height of a 9-story building, operated solely on the force of gravity. Water from the giant artificial Gatun Lake simply flowed down huge tunnels, carved directly into the concrete walls. By skillfully opening and closing massive valves, engineers forced the water to fill the lock chambers under its own weight. Nature was very elegantly and subtly harnessed for hard work here. The steel gates of the locks are a true masterpiece of engineering and industrial deception of the time. These huge structures, several dozen meters high, weighed many hundreds of tons each. At first glance, it seems that unimaginably powerful engines and an incredible amount of energy would be required to move them. However, the creators used a trick. The gates were made hollow inside, which completely changed the physics of the process. Half of their internal volume was completely airtight and filled with ordinary air. Thanks to this, the huge gates actually floated in the water like floats, despite their steel shell. Their buoyancy reduced their weight in the water to such a minimum that the gate could be moved by a single electric motor. The power of this motor was only 40 horsepower, which is comparable to the engine of a very small car. Giant ships could not enter these narrow concrete basins under their own power. Any mistake by the captain or accidental collision of the bow with the steel gates could lead to instant disaster. In such a case, water from the lake would rush into the system under enormous pressure, destroying absolutely everything in its path. Unique electric mules were specially created to fully control the movement of these huge masses. These heavy, squat locomotives, equipped with cogwheels, became a symbol of the canal's safety. With strong steel cables, they hooked the ship on 4 sides at once, firmly fixing it exactly in the center of the lock chamber. They guided the sea leviathans through a narrow concrete corridor with frightening, almost mathematical precision. The movement took place centimeter by centimeter under the complete control of the operators, excluding any accident. The entire canal system was completely enclosed, self-sufficient, and highly electrified for its time. The necessary energy was generated by its own hydroelectric power stations, which were powered by the same water from Lake Gatun. It was a perfect machine and a true pinnacle of early 20th century engineering. The locks became a kind of rigid corset that man was able to put on the chaos and wild power of the humid tropics. But the very basic principle of operation of this ideal and majestic machine initially laid the foundation for its future crisis. Every opening of the gates and every passage of a ship meant that tens of millions of liters of precious fresh water flowed into the ocean. The machine literally breathed this water, consuming it in enormous, frightening quantities. At the time, this resource seemed endless to people. But what would happen when the Great Lake began to rapidly dry up? In 1914, the canal opened. The illusion of ultimate victory was broadcast to the whole world. Steamships sailed from the Atlantic to the Pacific, saving thousands of miles and millions of dollars. The system worked like Swiss clockwork. The United States had gained its ultimate geopolitical tool. But as the global economy grew, so did the load on the system. The canal's structure was not designed for the scale of the future. Engineers in the 1910s designed locks for battleships of the First World War era. They could not have imagined container ships the size of the Empire State Building lying on its side. Ships grew larger. Their width came close to the walls of the locks. The gap between the steel hull and the concrete was reduced to a few dozen centimeters. Navigating a ship became like performing open brain surgery. The slightest malfunction in the electric mules threatened disaster. But the main problem was not the size of the locks. The main problem was the physics of water. The canal is a water bridge, and its supports are the fresh waters of Lake Gatun. The lake is replenished only by rain falling over the surrounding jungle. Trees retain moisture and slowly release it into the rivers that feed the system. In the second half of the 20th century, Panama's population began to grow rapidly. The jungle around the canal was cut down for pastures and cities. The forest, which was the main pump of the catchment basin, was disappearing. The balance was disturbed. Without tree roots, the soil could no longer retain water. During tropical downpours, water instantly drained into the lake, causing dangerous floods and forcing operators to dump precious resources into the ocean to prevent the dam from bursting. And during the dry season, rivers dried up and the lake level dropped critically. The system began to experience chronic thirst. Each ship transit washed about 200 million liters of fresh water into the ocean. With 30 to 40 ships passing through per day, the canal drank an entire lake per season. To maintain the water level, another dam, the Madden Dam, had to be built in the 1930s. It was the first attempt at rescue, the first crutch propped up under a weakening system. The canal required more and more infrastructure to survive. It began to dictate its terms to the entire region, taking water away from farmers and cities. By the end of the century, it became clear that the old shell could no longer accommodate the volume of world trade. Panamax-class ships became the limit. Shipyards around the world began building post-Panamax-class ships, giants that were physically unable to enter the 1914 locks. The canal began to lose its monopoly. Logistics was preparing to bypass it. A new surgical operation was needed, a radical expansion. But saving the old system always costs more than creating it. In 2016, Panama, which by then had gained full sovereignty over the canal, completed the expansion project. New colossal Neo-Panamax locks were built. They were wider, deeper, and longer. They allowed the passage of monstrous ships carrying liquefied gas in 14,000 containers at a time. Outwardly, it looked like a new triumph. Throughput capacity doubled. The tension seemed to have subsided, but the new locks required exponentially more water. To prevent Gatun Lake from drying up in a month, engineers implemented a system of reservoirs to conserve water. These giant tanks intercepted some of the water during locking and returned it back. Technically, it was a lifesaver. However, the price of salvation came from an unexpected source. The storage basins work on the principle of mixing. With each cycle, more salt water from the ocean enters the freshwater Lake Gatun. The salinity of the lake began to rise steadily, and Lake Gatun is the main source of drinking water for millions of Panamanians, including the capital. In saving global trade, the system began to poison itself. Fierce competition arose between a container ship carrying electronics for New York and a tap supplying drinking water to an apartment in Panama City. Water became not just a physical resource, but a political one. And then climate change struck. The El Niño phenomenon changed precipitation patterns. Tropical rains became unpredictable. In recent years, Lake Gatun has regularly fallen to critical levels. When the water level drops, the canal loses its depth. The administration is forced to impose strict restrictions on the draft of ships. This means that logistics companies cannot fully load their giant ships. Container ships sail half empty, losing millions of dollars. Traffic jams of dozens of ships waiting their turn for weeks accumulate at the entrances to the canal. Auctions for the right to pass without waiting are breaking records. Ship owners pay millions of dollars above the usual tariff just to get their ship through. The system created to speed up time has itself become a source of its loss. Today, the canal is a hostage to its own design. It cannot be deepened without water, and there is no more water to be had. Desperate, surreal projects are being considered. For example, diverting other rivers, pumping water over mountains, or building desalination plants specifically for the canal's needs. Each new attempt to maintain this water bridge costs billions and complicates the system to the limit. The original simplicity of the trench has turned into a fragile neural network of dams, salinity sensors, meteorological radars, and complex economic algorithms. The canal survived but lost its mechanical independence. It has become an intensive care patient whose vital signs are monitored every second. Look at this flawless water corridor again. At the ships gliding gently between the jungles under the scorching sun. You do not see the triumph of victory over nature. You see a temporary compromise that is paid for daily with enormous effort. Over the course of a century, the project has been transformed beyond recognition. From an ambitious idea for a straight cut, it has become a complex, climate-dependent water system. The canal is no longer just infrastructure. It has become hostage to precipitation, salinity, and global temperatures. We cut through this continent because power and speed carry weight, and that weight demanded a direct route. But large systems do not forgive scaling without consequences. Every ton of soil removed, Every cubic meter of concrete poured came at a price, and that price is chronic vulnerability. The external stability of the locks is only a facade, hiding an endless struggle for water and depth. The Panama Canal exists today not because it is durable or ingeniously designed. It exists because the global economy cannot allow this wound to close, continuously pumping money, concrete, and political will into it. The true history of this place is hidden beneath the surface of Gatun Lake and in the cracks of the Culebra Cut. It is a story about how matter cannot simply be subjugated to command. It can only be made to work for a while, but the bill for this work will be presented, and it will be paid until the fresh water runs out. The illusion of movement continues,